Lesson 12.7 Explore Similar Solids. Russian Matryoshka dolls nest inside each other. Each doll is the same shape, only smaller. The dolls are similar solids, same shape, different size. Similar solids are when they're the same shape but not necessarily the same size, like these two cones. The lengths of the sides are proportional. The angles are congruent, and the ratio of the lengths is called the scale factor. Congruent solids are similar solids with a scale factor of 1:1. And these following four conditions must be true. The corresponding angles are congruent. The corresponding edges are congruent. The areas of the corresponding faces are equal, and the volumes are equal. Notice angles and edges are congruent because they're shapes. Areas and volumes are equal because they're numbers. Okay, so that's if they're congruent. If they're just similar, the corresponding angles are congruent, and the edges are proportional. So, are these pairs of shapes similar, congruent, or neither? We have two cones. First one has a radius of 4.6 and a height of 12 and a slant height of 14.3. Second cone, cone B, has a radius of 8.6, height of 25, slant height of 26.4. Well, let's see. The ratio of the radiuses are 8.6 to 4.3. So that's just these two. That gives us 2. If I do the ratio of the heights, 25 to 12, it's 2.08. 2 and 2.08 aren't the same, so it's not proportional. So they're neither. Not congruent, not similar. Let's try a couple cylinders. The radius of the first one is 5.5, the height is 7.3. The radius of the second one is 5.5, and the height is 7.3. It's a 1:1 ratio. That means it's congruent, or they are congruent. Similar solids theorem. If two solids are similar with a scale factor of A to B, so in other words, that is the length, then the areas have a ratio of A squared to B squared, and the volumes have the ratio of A cubed to B cubed. So think of your units. Length is like just centimeters. Area would be centimeters squared, and volumes would be centimeters cubed. So with our ratios, length is just A to B, area is A squared to B squared, and volume is A cubed to B cubed. Let's say cube C has a surface area of 216 units, and cube D has a surface area of 600 square units. Find the scale factor of C to D. Well, our areas, because they told us surface area, and surface area. So we know our areas. So we can do C to D, so the little one on top, C's on top. It's 216 to 600. That reduces to 9 to 25. So that's our areas. That would be our squared. So it would be C squared to D squared. I'm using C and D instead of A and B because it's cube C and cube D. So the lengths are just C to D. The areas are the squareds. The lengths are not squared. So it means I have to square root, which means my ratio of the lengths will be 3 to 5, which is the square root of 9 over square root of 25. So the areas are squared. The lengths are not squared. So I had to square root those. Find the edge length of C. So this one actually we're just going to have to think about our surface area. If it's a cube, there are 6 sides and they're all squares. So our surface area would be 6 times the length of the side squared, because the area of a square is s squared, and there's 6 of them, so it'd be 6 times the side length squared. And our surface area of cube C is 216. Divide that by 6, I get 36. That equals my side length squared, so C is actually 6. So the side of cube C is actually 6. Now let's use the scale factor to find the volume of D. So the volume of C to D, alright, so lengths are just C to D, areas are squared, volumes are cubed. Volumes are cubed. Alright, the volume of C, though, would be 6 cubed, side cubed. The base is 6 times 6, and the height is 6, so it's 6 times 6 times 6. So I fill that in for the volume of C. Figure out the numbers. 6 cubed is 216. 3 cubes, 27. 5 cubes, 125. Cross multiply. 27 times volume of D equals 216 times 125. And divide both sides by 27, and you get the volume of D to be 1,000. Have a good day.